Let's get into this. Thanks for coming to my brief. It's Act Globally, Defend Locally. We're going to talk about connecting the dots with lessons from hunting terrorists, and we're going to tie that to cybersecurity data. A little bit about myself before we get started. I'm Dr. Tim Robinson. I serve at Worldwide Technology. I've been here for about 6 years, give or take. My background is management science and information technology from Virginia Tech, with a focus on decision support systems. After that, was a Marine Corps officer, 20 years. Somewhere in there, I got a degree in operations research analysis. What that means to you is I'm a guy who likes to use math, right? I like to use data to help decision makers make decisions. And then following that, if that wasn't enough, I had to go and get a doctorate in cybersecurity. More on that later. It'll all make sense, I promise you. Let's jump into this brief. So I know a lot of you have heard, those who don't know, history is doomed to repeat it. And a lot of times in the US government, when we're talking about sharing data across organizations and agencies, whether it's technology-based, doesn't really matter, we cannot overlook the things that happened during 9/11. Now, we'll put a pin in that. We're going to talk a little bit about that, but I want to talk about what happened after 9/11, because connecting the dots, man, I think we missed a couple of things. Does anybody remember, right off the bat, I also talk fast, so you guys are gonna have to go along for the ride. So does anybody remember the Christmas Day underwear bomber guy? Does anybody remember that dude? And I wanna bring this up because to me, a couple of dots I think was missed. I keep doing this. What's the guy from Green Bay? Like the discount double check thing. I'm just trying to give you guys this mindset of this dude legitimately had bombs strapped to his underwear and he's gonna try to blow up an Airbus 330. I'm like, what kind of life decisions are you making, right? Craziness, I'll tell you. Now, anybody know how big an Airbus 330 is? Actually, it's on the slide. I gave you the answer. So 300 people were saved that day. So great, good job, America. We love to see that. Now, let's talk about the dots that drew my attention. 4 months before this guy tried to jump on an Airbus 330 to blow it up, NSA learns that Al-Qaeda in Yemen is going to use a Nigerian prince. Actually, it wasn't a Nigerian prince, I made that up, but a Nigerian man, we're going to come back to that later, to do some bad stuff. And if you guys got an email from the Nigerian prince, some of you have got that email. Quick story, I'm gonna do this a lot. Quick story. So my name is Tim Robinson. Tim Robinson. There are 7 of us at Virginia Tech. 7 Tim Robinsons at Virginia Tech. I'm gonna talk about my doctorate here in a little bit, but Tim Robinson, my doctorate was in about cyber attack. We're gonna get into that later. I'm like the most hackable person on the planet. So I'm just telling you now, if you ever do anything about terrorism and cyber attack and you have a simple name like mine, you're gonna get spammed. Getting back to the story. So 4 months, NSA gets himself. 2 months after that, UAF, I won't give you the guy's name, but his father told the State Department, hey, State Department, hey, CIA, my Nigerian son has fallen in with Yemen extremists and he's going to do some bad stuff. Yeah, it's crazy. No, right? Like all of this information we should have had, we should have put it together. Now, we'll put a pin in that and we'll come back to it later. Ian Millizer wrote a report, and I want to read what he's saying. Now, we're talking about data sharing, right? He says, rather the intelligence community fail to connect the dots because they haven't built the IT infrastructure necessary to support this ambitious policy. This ambitious policy meaning that, hey, we want to share data across the US government, right? 9/11 Commission reports also had some interesting findings. The importance of integrated, and I want to highlight integrated because every time I walk into a customer space, hey, Dr. Tim Robinson, I got the new hotness already. I have information technology, I have data. This new stuff that you're talking about, can you help me integrate that? I want to leverage the current investments I have and integrate this new stuff. So integration is a large part of what we deal with at Worldwide day in and day out. What am I trying to say? Not only do we have a data sharing problem, we also have a data integration problem with IT infrastructure. Now, who's going to solve this? Enter NCTC, the National Counterterrorism Center. Now, this was incredibly funny to me because I'm going to read this and then it's going to be crazy. To serve as the primary organization for the United States government for analyzing and integrating all all intelligence possessed and acquired by the U.S. government. All intelligence. I'm like, dude, I don't want that job. I don't know anybody here want that job. I mean, that's a very tough job. Huge organization doing incredibly cool stuff. And I know what you're thinking right now. Hey, Tim, we keep talking about counterterrorism. We're supposed to talk about cyber. When are we going to talk about some cyber? Glad you guys asked. Turns out, plot twist, when you're looking for cyber threats, it's much like hunting for terrorists. And also, I'm a cybersecurity guy. Everything is about cyber. Everything is about cyber. I'm going to say that till I'm blue in the face. Everything's about cyber. Now, by me saying that, I have to do this shameless plug. I brought up my dissertation earlier. Now, as an educated guy, I typically don't make theories without data to back it up, and this time I will. So if you have your cell phone, this is off script, by the way. I told you I'm going to do this a lot. You got to go along for the ride. Work with me right before lunch. So look up Dr. Tim Robinson and look up cyber attack dissertation. In that, you'll find my dissertation. In my dissertation, I talked about how to hunt for cyber threats. I mean, I was in my zone, like writing Python, C++, S+. I was doing all kind of cool stuff, utilizing what? Utilizing one piece of software, one person. What software did I use? Man, you guys are kind of... Nobody can guess what software I used in my dissertation to look for cyber threats? Nobody? Elastic, oh my gosh, thank you. He bailed me out. Okay, so that was a sidebar. Let's get back to the presentation. Okay, what is this slide really about? Really, I just wanted to show that our adversaries don't fight fair, right? They will come and try to take everything that we have, utilizing every widget they possibly can. Now, we, likewise, have to think along the same way. We don't use pickup trucks to fight. Maybe we do, but typically we have purpose-built weaponry. Same thing you should do as it applies to data. Now, getting back to this whole idea of connecting the dots. The government runs one of the largest networks on the planet, right? We're supposed to be we're supposed to be talking to one another, right? So let's do the math. So Army has about how many endpoints? You got about 480,000. I'm doing air math. So Army has about 480,000. Marine Corps has about 175,000. I tried to do this math last night, but I totally messed it up. Bottom line is, if you're looking at DOD, and just DOD, you're talking about what, 1.5 million endpoints? Now, extrapolate that, NCTC, across the whole of government, you're talking 8 million, 10 million endpoints. Dude, all of those are sensors. All of them have a story to tell. How do we then connect the dots in a manner that's efficient for us to make decisions that will help save lives, right? Very important thing to think about. Analysts need to have access to data, no matter where that data lies. So we're going to talk about reality, and then we're going to talk about how things we would like to be. So here's my dot connectors at the bottom. You see Ash, you see Shy, you see Braden, Joanna, a bunch of those guys at the bottom. I'm an analyst. I told you that. I'm one of the dot connectors. How many here would love to have the data in one data store? Because everybody would like to have all their data in one data store. That's like the Matrix. That's the blue pill. The blue pill, you have all your data in one data store. The red pill is reality. This is what it looks like, right? You have data stores here, data stores everywhere, terrorist data, cyber data. Now, your dot connectors don't change. They just have this job that they have to put this stuff together to make sense of decisions. It makes sense with the decisions that they have to make. Now, unless you're going to change and look like this, you have to do something differently. You have to think differently. Now, this, if you hadn't figured it out, this presentation is not anything technical. I just want to get you to think about how you go about this problem of consolidating data. Now, anybody play golf? A lot of people play golf. Walt Smith plays golf, right? When he hits the ball, it's right down the middle of the driveway every single time. At least that's what he tells me. But when I hit the golf ball, it's everywhere. Do you think Walt allows me to go and move that ball to where it's more efficient for me? Absolutely not. You have to play the data where the data lies. Putting all your data, hashtag BDP, in one location, that is just not feasible. It's not the way you do it. You have network limitations, you have policy limitations. Oh, by the way, you have cost. You got to pay to move that data, right? And if you're a tactical unit, it's unfeasible. More about that later. Now, You also have to do something else. Hey, Tim, you have to give people access to the data. Now, I'm not here to talk about identity and access management. You could get SailPoint, you could use Okta. Doesn't really matter. The bottom line is we're talking about playing the data where the data physically is. You unify the data logically and not physically, meaning you don't push all the data back to a central location. Now, I'm a Marine, and I'm trying to do, I hate to get into this. Yeah, let's do it. Let's talk about the story. So when I was a Marine, I was forward deployed. I think it was like 2001, 2002. This is before we pushed over the berm in Iraq. This is before we pushed over the berm. I was a second lieutenant. We had a mountain where we had all of our antennas. We had what's called a tactical data network, TDN tactical data network, and we had a technical control facility. So all of the data comes in from the step site to the technical control facility, right? And it goes to the TDN, and then it gets pushed up to the COC. We took incoming a lot, and we did a lot of backhoeing and stuff like that, probably broke some of our own fiber. But the bottom line is, you tend to lose connections every now and then if you're forward deployed. This is another reason why you should not bring all the data back to one location. You should play the data right where the data is. Bottom line is we're leveraging global data for local defense, and we're going to get more into that later. Now, let's talk about how we can make this actionable. We talked about on the right-hand side, sorry, I got to look at the side. On the right-hand side, this is bringing all the data back to one location. On the left-hand side, this is centralizing the data and accessing the data logically. And you can do a lot of cool things by doing this. And oh, by the way, shameless plug number 2, we've done that. We have a booth over here. Go to worldwidetechnology.com. Look for UCP, Unified Cyber Platform. And I'll just briefly read this. Sorry, I don't have my high definition on. I don't want to mess this up. It's an innovative, scalable, portable, yet flexible solution that integrates several technologies to collect and analyze log data across several networks and combine it for security, orchestration, automation, and response. Everybody know what SOAR is? If you're doing stuff and you're not leveraging SOAR, you're not actually accessing your data and leveraging things with SOAR, you're probably behind. Let me give you another story. Every time I walk in and I talk to customers about COC-related stuff or NOC-related stuff, they'll say, hey, Dr. Robinson, I have 500, maybe 600 alerts a day that I look at, right? I'm like, hey, you have a SOAR problem. You know what I mean? Number one, you need access to that data, but also number 2, you need to be leveraging things like SOAR to make use of that. That was for free, not in my brief. I gave it to you for free. So now let's move on. So once we get the construct and the mindset that we're going to centralize data logically, play the data where it lies, not bring all the data back, we can do cool, sexy stuff, right? One of the cool, sexy things I like to talk about is federated machine learning. But Dr. Robinson, we do regular machine learning. What's this federated machine learning stuff? I'll try to talk about it a little bit. I said I wasn't going to be technical, but you guys I got to give the people what the people want. You want to learn about federated machine learning. So I'll try to talk a little bit about it, and then we'll move on. So federated machine learning is much like, it's machine learning, but it's doing things geographically separated, doing things logically separated. In other words, let's just say this. I can bring all the data back to me. I could run my machine learning models on it. The problem is I'm still in the same blue pill construct. Bringing the data back is very hard. It's untenable. So federated machine learning allows me to run run models at the distant end. What happens is you build a new model at the distant end, and you no longer send your data back. You send your weights, you send your parameters, you send your information back that you can then build a new model back at your centralized location, and then you can leverage that model. Why, Dr. Tim, are you talking about this? One of my many hats that I have, I don't do this anymore, but I used to be an operator. Most of you know what an operator is. I try to get into networks, right? I use different TTPs. I think Joanna talked about different TTPs. She talked about the MITRE framework earlier. I tried to get into networks. And once I got in a network, what's the first thing that a hacker does when he gains and he elevates privileges once he gets into his network? Where does he go? He goes laterally. Man, somebody get that guy a drink. He goes laterally. That's exactly what I would try to do. So if you're seeing things pushed out forward, you got your machine learning model, you're doing your thing, you're hooking and jabbing, you're like, hey, I got a bad guy. And it's forward. What do you think that bad guy's going to pivot to? He's going to pivot back home and try to do the same things that he's doing out forward back home. So wouldn't it be nice to have those same models funneled back to me? Absolutely, and we're doing the same thing. We're playing the data where the data is. We're sharing what is needed so that then we can become more effective. Earlier, I talked about this thing about cross-cluster search, and if I didn't, I apologize, but that's exactly what we're talking about. We're not just, this is about 3 slides, but we're not just going to do things here, we're going to do things at a distant end. So let's talk about cross-cluster search for a little bit. So a user sends a cross-cluster search request locally, right? There's a coordinating node there, and what that coordinating node does is it receives the request and he parses it. After he receives it and he parses it, he pushes it out forward to the other clusters. Now, he's not going to project to the cluster what the cluster do. The cluster has its own parameters, right? But what he's going to do is he's going to organize it such that once the cluster performs its search independently, it's going to apply its own cluster level settings to the request, and he's going to send it back to the coordinating node. Once the coordinating node gets everything and puts and parses it all together, the coordinating node returns the final results of that cross-cluster search response. Now, there are many other ways you can do cross-cluster search. This is just one way that I like to do it. It makes sense. My point to you is this: if we have all of this functionality native in Elastic, why don't we use it? Once we get stuff like this set up, it's much easier to do things like federated machine learning, to where you can actually run models out front, build new models, send that information back to your home base. Then you can leverage what's happening around the globe. In summary, I don't know how much time I have left. I got 3 minutes left. All right, let's talk a little bit more. Bottom line is, developing a federated data strategy can serve as a powerful weapon. I talked about playing the data where it lies. I talked about using purpose-built weaponry. I look at Elastic as purpose-built weaponry. When I was doing my dissertation looking for cyber bad guys and PCAP data, it was a tool that I was able to go in. I mean, it's pretty cool. I was able to do clustering. I was able to do freaking moving averages. I was able to do k-means learning. I was doing all kinds of things just by leveraging the native functionality in Elastic. I'm telling you guys, it's pretty easy to do. You just have to do it. Come talk to me. I'll be over here this afternoon to talk more about it. Playing the data where the data lies can provide a capability yet operate locally disruptive. Remember I gave you that story about we were forward deployed. We were taking incomings. I'm throwing Marines in bunkers, trying not to be the guy that get hit by an ID or something like that, or indirect fire. But we had to fight through that stuff. And by us separating things logically, it helped us understand that, hey, if I lose my tech control facility, can my combat operations system continue to work? It absolutely could, because we're smart enough to plan for that type of thing. All right, federated machine learning can allow cross-domain and interagency collaboration across data. One thing I like about this federated machine learning as well is you never send all the data back. Remember I told you send parameters, you send weights and distributions back. You don't send all of your data back. So not only are you not clogging up your pipelines, you're not sending all of the data back, so it's not going to increase your attack surface. Lastly, I want to click on this again. This technology exists today, man. The bottom line is, why aren't we using it? Again, my name is Tim Robinson. Thank you for your time.